Okay everyone, so here we're going to work through some basic integration examples just to get us used to the idea of working with integrals. And in all of these examples, these are definite integrals, so they have limits. So the first one that we have here is square root of x dx, and we're taking its integral from 0 to 4. All right, so first thing we want to do here is realize that square root of x is the same thing as x to the 1/2. So really what we're doing here is the integral from 0 to 4 of x to the 1/2 dx. Okay, so we can use the power rule on this one. We know that to use the power rule, we raise the power by 1 and divide by the new power. So this is going to become x to the 3/2. So we're going to raise the power by 1 and divide by the new power. All right, and we're going to evaluate that between the limits. And I like to write that in brackets like this, 0 to 4. Okay, so if we go through this, so we have 4 to the 3/2, which is 8. If you take 4 cubed and then take its square root, and then we have to divide that by 3/2. So 8 divided by 3/2 is 5.33. If we take 0 to the 3/2, all right, we get 0 over 3/2 is 0. So minus 0. So our answer is 5.33 for this example. Okay. For the second one, we have the integral between 1 and 2 of 5x squared minus 4x plus 3 dx. Okay, so to integrate this, we're going to use the power rule again. So we're going to raise the power by 1 here. We'll get 5x cubed over 3. 5x cubed over 3. For the second one, we'll get 4x squared over 2, which 4x squared over 2, that reduces to 2x squared. And then for 3, we get 3x to the 1. Again, we don't need a constant of integration since we're doing a definite integral here. And we're going to do that between 1 and 2. Okay, so now we can evaluate this. We have 2 in for x, so 2 cubed is 8. 8 times 5 is 40. 40 divided by 3. So we have 40 over 3 minus. Here we have, plug in 2 for x, we get 2 squared is 4. 4 times 4 is 16. 16 over 2 is 8. And then plus 3 times 2, which is 6. So that's our upper limit. And then our lower limit, if we plug in 1 for x, we get 5/3 for the first term. For the second term, we get 2. And for the third term, we get 3. Okay, so we'll need to clean all that up. What we'll get here is, we could say 40/3 minus 24/3 plus 18/3. Could do it that way if you'd like. All right, and then we have minus 5/3 minus, this is 6/3 plus 9/3. So we got lots of thirds here. All right, so 40 minus 24 is 16. 16 plus 18 is 34/3. And then over here we get 5, excuse me, 5 minus 6, and then plus 9. So we have -1 plus 9 is 8. 8/3. So this whole thing 34 minus 8 is 26 over 3, and we can leave it like that for now. Okay. The next one is the integral of sine of t dt between the limits of pi over 4 and pi over 3, and these are in radians. Okay. So the integral of sine is negative cosine, so we get negative cosine of t between the limits of pi over 4 and pi over 3. So we got to think about our trig rules here. All right, so pi over 4 is 45 degrees. So the cosine of that is root 2 over 2. And if we do pi over 3, that's 60 degrees. So the cosine of 60 is a half. So we have negative 1/2 and minus the lower limit, which was root 2 over 2. All right, so I can write that this way and go like that. Or, since there's a negative sign outside, just turn that around and write it this way. And you can reduce that in your calculator if you like. Okay. The last one is the integral of 8e to the x dx. You could pull the 8 on the outside of the integral here. Since e to the x is its own integral, I'm not even going to mess with it. I'm just going to call it 8e to the x, and we're going to go between natural log of 6 and natural log of 3. So if we plug in natural log of 6 for x, we get e to the natural log of 6, so that's 6 times 8, that's 48. And then if we plug in natural log of 3 for x, we get e to the natural log of 3. Well, that's 3 times 8 is 24. So we get 24 as our answer. So these are just some practice examples using basic rules for integration.